Hello viewers and welcome to my YouTube channel. Today, as usual, we are going to provide a solution to x, y and z in this simultaneous equation, and we are going to solve this particular simultaneous equation by elimination method. This particular equation we are seeing clearly written on the board is just an extension of that simultaneous equation with two unknowns, but in this case we have three different unknowns, and we must have to reduce it to two unknowns so that it can easily be handled. So follow me, let's solve the equation together. But if you are watching my video for the first time and you know that you haven't subscribed to my YouTube channel, kindly pause this video and hit the subscribe button, and also turn on the notification bell so that anytime we upload video you'll be notified. Thank you so much. So follow me, let's solve the equation together. So solution, let me call this 1, let me call this 2, and let me call this 3. So let's start with the first equation and the second equation. And the first equation says 9. So in elimination method, we have to eliminate either the first, the second, or the third term. Our first term here is x and 2x. Our second term here is y and minus y. Our third term here is z and 3z. So I want to eliminate the first terms. So in order to eliminate the first term, we have to make them to be the same. I have x here, I have 2x here. That means I need to make the two to be the same. So if I multiply this by 2 and this by 1, because multiplying the second equation by 1 will change nothing to the result or to the appearance of the equation, and multiplying everything here by 2 will make this x to be 2x. So that means we will succeed in making the first terms to be the same. So multiplying this by 2 means I will have 2x plus 2y plus 2z is equals to 12. And multiplying the second by 1 means I will get the same 2x minus 1 plus 3z is equals to 9. So since we were able to get the first term to be the same, so we are going to eliminate them. That is why the system or the approach is called elimination method. So I want to eliminate the two. I want to remove the first term. So in order to remove them, I need to subtract. It is not all the time that we subtract. It depends on the situation. Sometimes the situation might not allow you or permit you to subtract. Sometimes out of necessity we need to add. It depends on which term and what signs the term has. So, and secondly, in eliminating a particular term, we need to be more consistent or to be more specific. If we are eliminating the first term, it has to be the first term all through. If we are eliminating the second term, maybe as the case of y, it has to be second term all through. And so also, if we are eliminating the third term, it has to be the third term all through, so as to avoid the tendency of committing an error. So thank you. Back to our equation. I said that we need to eliminate the 2. So 2x minus 2x is 0. So let me draw a line. 2y minus minus is plus. So that means 2y plus y is 3y. So 2z plus minus and plus is minus. That means 2z minus 3z is minus z is equals to 12. Let me put the equality sign very well. 12 minus 9 is 3. So we can see that we have one equation with two unknowns, that is y and z, and it is a very important equation. So let me put NT. So note that this is a very important equation. So remember that I started with equation 1 and equation 2. Now I want to join equation 1 and equation 3. So equation 1 says x equals 4. So ideally we have to make the first and the these first terms to be the same. That means if the terms are not the same, but in this case we can see that the first term of the two equations are the same, so there is no need of multiplying one by certain number or certain integer, or by a second equation by certain integer. All we need to do is to eliminate, since we have succeeded in getting the first two terms, yes, the first term of the two equations to be the same. So all we need to do now is to subtract second equation from the first equation. So let's subtract just the way we did here. So x minus x is actually 0. So, and y minus plus is minus, so y minus 2y is minus y. Z minus minus is plus, that means z plus 3z is actually plus 4z is equals to 6 minus minus is plus, so 6 plus 4 is 10. So we can see another important step. So let's form our new simultaneous equation containing two unknowns, two equations, two unknowns, and this is what all of us are familiar with. So this is now going to be our first equation, 3y minus z is equals to 3, and let me call it my original equation 1, and minus y plus 4z is equals to 10, and this is my original equation 2, or the equation I just formed. So I can see that this is a simultaneous equation we are all familiar with. So we can solve this particular simultaneous equation by either substitution, elimination, graphical, or sometimes we may even think of solving it by matrix form. So let me solve this particular equation by means of substitution. So in substitution, you pick either equation 1 or equation 2 and make a particular variable, either the first variable or the second variable, to be the subject of the formula. So now let me pick equation 1. So from equation 1, we can see that 3y minus z is equals to 3. So I want to make z the subject of the formula because the coefficient of this z is 1. It seems simpler, so let me make z the subject of the formula. That means I'll have minus z is equals to 3 minus 3y. So I want to get rid of this negative. That means I need to divide it in, each individual term here by minus 1 minus 1. So that means my z is now minus 3 plus 3y. So my z is now the same as 3y minus 3. And let me call it my new formed equation 3. So since it was equation 1 that generated this equation 3, now let's relate this with equation 2 and see what will happen. That means anywhere I see z in this equation 2, I will put 3y minus 3, and that is why we call it substitution method. We are now going to substitute for z in this particular equation. So equation 2 says we can write it from equation 2. Equation 2 says minus y plus 4z is equals to 10. So minus y plus 4, instead of z, I'll open bracket, since we already have the value of z, 3y minus 3 to be equals to 10. So minus y plus 4 times 3 is 12. This is y minus 12 is equals to 10. So minus 1 plus 12 is 11y is equals to 10 plus 12. So 11y is equals to 10 plus 12 is 22. So I'm looking for y. I need to divide both sides by 11. So my y is now equals to 2. So we can see that our value of y is equals to 2, and we have a particular equation that says z is equals to 3y minus 3. So we can use this particular equation, that is equation 3, to solve for z by substituting the value of y in the equation. So let me clean here. So since the value of y is 2, let me use this equation and solve for z. So z from equation 3, z is now equals to 3y minus 3. So if the value of y is 2, that means z will now be equals to 3 open bracket 2 minus 3. So z will now be equals to 6 minus 3, and z will now be equals to 3. So I can see that the value of z is 3. So, but don't forget that we have 3 different unknowns, x, y, z. And now that we've succeeded in getting the value of z, y and z, how can we get the value of x? Is by substituting the value of y and z in either equation 1, 2, or equation 3. So let's pick from equation 1. From equation 1, but the equation 1 here is this equation 1, our original given equation 1. So x plus y plus z is equals to 6. That means I have x plus my y is 2 plus my z is 3 is equals to 6. So x plus 5 is equals to 6. So x is now equals to 6 minus 5, and x of course is equals to 1. So we can see that x is equals to 1, y is equals to 2, and z is equals to 3. And these are the values of respective values of x, y, and z that will satisfy these 3 equations. Someone may decide to check by putting in the values of x, y, and z back to either equation 2, 3, or 1 and see whether the equation will balance. Thank you so much for watching.